Hi everyone, welcome back to the channel. So let's solve this problem today. This question was asked in IIT JEE 2016 Advanced. I think it was in paper 2. And this is pretty interesting question. Although the question seems very long and daunting and complex, but trust me, this is a simple question. The JEE will not ask any question which is going to involve too much of computations and too many steps, but it will definitely try to test your logical analysis, and given a new thing, can you solve that particular thing? So here, although the concept should be clear to more or less everyone, but still, if this is not clear, then I will go into the detail and cover you some of the concept here. But even if, let's say, you don't know anything about this equation or this problem, you should be able to do this pretty easily if you just follow these steps. And probably that's why the IIT JEE gave you this equation, because they really wanted to help you with these steps also, what need to be done. And these questions are nothing but the steps. So if you do the first step, you will get this one. And the second step, you will also get this one. Okay. So let's try and get into this problem. And along the way, I'm going to give you deep concepts here, and you should definitely watch it. And once you understand the concept, you will be able to solve such questions very easily, and many other related questions that JEE has been asking over the period of time. Okay, so let's get started. First point is that frame of reference that is accelerated, right? So this is talking about an accelerated frame of reference. So typically we talk about two frames of references. So one is that lab reference, where we watch something happening when we are sitting in the lab. And there is an accelerated frame of reference, which means that we are actually on that object which is accelerating. The frame itself is accelerating. Okay. Now here, the accelerated frame of reference is nothing but this disk which is rotating. So if you see, this disk is rotating with constant angular velocity, but still it is an accelerated frame, because the direction is continuously changing. So hence, although the direction of omega is not changing, but when we sit here somewhere, our direction, the radius vector, will keep changing. Not the magnitude, but the direction. Okay, so now let's see what's going on. A frame of reference that is accelerated with respect to an inertial frame of reference. So there is an inertial frame of reference. You can treat this as a lab frame. Is called a non-inertial frame of reference. So non-inertial frame of reference is something which is accelerated. Not the inertial frame. Inertial frame might be moving, but with constant velocity. Acceleration may not be there. Okay. And they have defined the coordinate system. So if you see, the coordinate system is actually, this one is Z, and this one is Y, and over here, this side, it is X. Coordinate system fixed on the circular rotating disk about a fixed axis with a constant angular velocity omega is an example of a non-inertial frame of reference. The relationship between force experienced by the particle of mass m, so the relationship between the force F rot is rotational frame of reference, non-inertial reference frame, and the force that is being experienced by the particle of mass m moving on the rotating disk with the force F in, which is inertial frame, force experienced in the inertial frame. This is the equation. Okay. I will explain a little bit when we start solving this problem. What is this? And this is typically, you might already be knowing about it. Where V rotational means that rotational frame of reference is the velocity of the particle in the rotating frame of reference, and R is the position vector at any point in time. Okay. Now, at certain point in time, let's say t equal to 0, there's a block of mass m. Okay, so now consider a smooth slot along the diameter of the disk of radius r, rotating counterclockwise with a constant angular speed omega. Okay, we assign a coordinate system. As I just described, the coordinate system has been defined like this. A small block of mass m is gently placed on the slot at r equal to r by 2i. So this is, as you know, this is also I, right? We can call it I. This is J, and this is K. Okay. At t equal to 0, and it's constrained to move only along the slot. So there is a slot here, so it cannot move anywhere else but along the slot. And then it is asking, find the R of the block, the radius, at any time t. And the second question is, what is the net reaction of the disk on the block? Okay. So these two things we need to answer. What is the difference between inertial and non-inertial? And this is also accelerated or rotational. Okay. So the difference is that pseudo forces act in non-inertial frame only. You must remember this. Okay. This is important point. And if you see this equation is F rotational equal to F inertial plus 2m into omega, this is rotational, plus m omega into r. Now let's check this one first. Okay, this one, because this is simple one. This is nothing but centrifugal force. Okay, so this part, let's say this is Fa and this is Fb. Okay, so Fb is nothing but centrifugal force. And you might already be knowing the magnitude of this is m omega square r, mv square by r also we said when v is equal to omega r. Okay, right? You might be aware of this. Now let's see what is omega. Omega is omega into k. It's given, right? It's right here. Okay, and r is nothing but r into ri. R is in the x direction. So let's calculate Fb, m omega k into ri into omega k. Now omega k into I is what? K into I is omega rj into omega k. These are cross product, by the way. These are cross product. Okay. So this is now m omega r into omega j into k. What is j into k? I. So that is m omega square r I. So Fb is in I direction. Okay. You get it? Okay. Now let's see the Fa. Fa is called Coriolis force, and it only acts in a non-inertial frame because it's a pseudo force. So what is the meaning of Coriolis force? Why does it exist, right? So the first thing is, if you have a situation, let's say imagine a disk which is rotating like this one, and let's say you are standing here and walking towards the center. So there is a radial velocity for this person with respect to the disk. And if I am standing here, I am watching here, let's say this is my frame of reference. I am looking at this person's movement from the rotational frame. Then I see that this guy will experience a force. Now imagine if you are standing and going towards the center, you will, and if it is rotating in this direction, then you will face a force in this direction, okay, on the parallel to the disk, but in this direction. And you will have to somehow, with use of friction, manage in order to remain on this line, this radial line. Otherwise, you will just slip off the disk. Okay, this force is Coriolis force. So when there is a relative movement in a radial direction on a rotating frame, and if I am watching this motion from the non-inertial frame, then this Coriolis force will act. Okay, now how do we define it, right? How do we compute it? So let's take this person's movement. Okay, torque is defined as dl by dt, right? So let's say L is nothing but I omega, which is mr square omega. Now let's just differentiate this. Okay, dl by dt, because we need to compute torque, and that will be m omega dr square by dt and plus m r square d omega by dt. So this is 2m omega r dr by dt plus mr square d omega by dt. Okay. Now, if suppose I put a constraint like this one, that this person is always moving in this line, it's not going anywhere else, right? Because this guy is also rotating with the disk. So therefore, there is no angular acceleration for this guy, as long as he's walking in the radial line. Like in this question, it is mentioned that this block is forced to move in this slot. So which means that there is no motion for this block in this direction or any other direction. So which means that the d omega by dt must be 0, right? If it is not 0, then he will get accelerated. So the only thing which remains is 2m omega r, and this is nothing but v. Okay. Now I am just dealing with the absolute value of torque. So the force here is 2mv cross omega, and hence torque is r into f. So this expression is nothing but Coriolis force. Okay, so typically it acts on the body in the direction of the omega. I mean, if you take it is going in this direction, so the force will act here, and this guy will have to apply, using friction and force in this direction to balance himself. Hence there will be a torque also. Okay, so this part is theory. Now let's get back to our question. So here the FA is, it's also given here that V rotation, the V in the rotational frame into omega, and this is V is nothing but V I into omega k, therefore 2mv omega I into k is minus j. Okay, so there is a minus 2mv omega j, and this expression tells us that the Coriolis force is acting in the minus j direction. Okay, which is fine also, we figured that out as well. Okay, so there are two forces that we computed. Okay, I just showed you here for the clarification. In the examination you don't need to do this, you simply need to take this and compute what is being asked. But this is just to clarify that these expression is nothing new for you. You know that there is a centrifugal force, and then you know that there is a Coriolis force. Okay, now let's compute the R. Now how do we compute it? So we know that the centrifugal force is acting in the I direction and the Coriolis force is acting in the J direction. There is a weight for this guy, this mass, which is acting in the minus K direction, right? So this much is now known. So what is the acceleration here in the I direction? So the I direction acceleration is omega square r. We just computed it right here. Right? F equal to m omega square r. So A is omega square by r. And how do we write A? We can write A as v dv by dr equal to omega square r, and therefore we can have v dv equal to omega square r dr and integrate these two, r by 2, 0 to v. So that means v square by 2 equal to omega square r square by 2, r by 2 to r, which is omega square by 2 r square minus r by 2 whole square. Yep. Therefore, v is plus minus omega r square minus r by 2 whole square root under, right? Now, we could really solve it in an easy way to find out the equation. Okay, or we can just do it hard way. Let's first do it the hard way, just to give you the sense like how to compute this entire thing in a simple manner. Okay, so let's just take the plus omega for now. Okay, we can just take it as dr by dt as omega r square minus r by 2 whole square, and then what we get is dr by r square minus r by 2 whole square omega dt, right? Solving this expression is not difficult. We simply can, let's say, we can do some rough work. We can just simply put r equal to r by 2, let's say sec x. So dr is r by 2 sec x tan x dx, and r square minus r by 2 whole square is r by 2 whole square sec square x minus 1, which is r by 2 whole square tan square x. Therefore, this integration to sec x tan x dx divided by r by 2 tan x. Remember, this is inside the root, right? So which is this r by 2 tan x will cancel out. It will simply become sec x dx, and sec x dx is nothing but ln sec x plus tan x. Okay, so we can just, and what is sec x here? Sec x is nothing but 2r by r, and plus tan x is sec square x minus 1, so which is 2r by r whole square minus 1, right? And therefore this is ln, and write r plus r by 2 minus 1 and divided by r by 2. Okay, so then we can write here ln r plus r square minus r by 2 whole square divided by r by 2 omega t. Okay, therefore r plus r square minus r by 2 whole square by r by 2 is e omega t, right? I mean, and then we can have r square minus r by 2 whole square as r by 2 e omega t minus r, and if I square both the sides, two omega t plus r square minus 2r by 2 r e omega t. Okay, now this will simply just cancel out. Okay, so we take this one this side, so it becomes r e omega t equal to r by 2 whole square e 2 omega t plus 1. This will move the side. Okay, and therefore r is r by 4 e omega t plus e minus omega t. Okay, that's the expression, and that's also there in one of the options here. So if you see this one, A is the right option. Now, we didn't actually need to do so much, because if you see here, this, okay, let's just do it once more. We can write A as V dV by dr is omega square r. That means V square by 2 is omega square r square by 2, and which means V is plus minus omega r. Okay, and you take V equal to omega r, then this is dr by r equal to omega t, that is ln r equal to omega t, and therefore r is e omega t. And if you take V equal to minus omega r, using the same approach, we get ln r as minus omega t, therefore r is e minus omega t. So this is a parallel differential equation, and we can simply say that the actual equation will be sum of these two with, let's say in this case it's a constant amplitude, so a e omega t plus a e minus omega t, therefore a e omega t plus e minus omega t. And we know that at t equal to 0, r is r by 2, it's given that, therefore r by 2 equal to a 1 plus 1, which means a is r by 4, and therefore we get the equation as r by 4 e omega t plus e minus omega t. This is a pretty straightforward and easy solution, and this is perfectly legal. You can use this. With both approaches we get the same answer. Okay, so now we got the r. Now what is V? We need to compute V to compute the Coriolis force, because remember F Coriolis, the Coriolis force is 2 m 2 V m V omega, right? This is the force. So what is V? V is nothing but dr by dt, and if you use this one, you get r by 4 omega e omega t minus e minus omega t, right? And so this is the V, so F Coriolis will be 2 m r by 4 omega e omega t minus e minus omega t into omega. Okay, so we get half m omega square r e omega t minus e minus omega t. So this is the Coriolis, the magnitude of Coriolis force. What was the direction that we found? The direction was minus j. And what is the direction for weight? It is in minus k. So the total force acting on the body, force on body, is minus half m omega square r e omega t minus e minus omega t j minus mgk. Now the question is asking the reaction of disk on the mass. So we know that using Newton's third law, the reaction force will be just opposite, equal and opposite. So it will be half m omega square r e omega t minus e minus omega t j plus mgk. Okay, and this option is also there, okay, in the question. So we can B. So B is the right answer. Here A was the right answer. Okay. To just a quick recap, pseudo forces only acts in non-inertial or accelerated frame. Okay, it doesn't act in lab frame, because in lab frame they cancel each other, the reaction and the action. And this is the force equation given in a non-inertial frame or rotational or accelerated frame. This is a Coriolis force which is acting because if the body is moving in a radial direction in an accelerated frame. Okay, this is a radial direction movement because this body is moving towards the radius, towards the center or away from the center. It's the radial direction. And this you already know, this is nothing but the pseudo force. That's it. And you use the vector multiplication to know the direction and you will get the answer. Okay. I hope you understood few things and you got some of the concepts clarified. Please do subscribe to our channel, like this video and share it with your friends. Thank you very much. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.